asked to determine the exact value of this unusual angle expressed in radian form, 13 pi over 12. In order to calculate this exactly, what we need to do is figure out what two common angles, special angles, would add up to 13 pi over 12. And I think I know, because this is a 12, I suspect that this is the sum of 3/4 pi and pi by 3. Sure enough, if I do the math, this is 9/12 and this is 4/12, which makes 13/12. Now I can actually put this into my compound angle formula for sine. And so I just have to check and make sure that I've done everything correctly. Sine cos, cos sine. And so now I'm ready to put in my exact values because I know the values of these ratios. So 3/4 pi, sine is always positive in this quadrant, which is quadrant 2, 1 over root 2. Cos of pi by 3, first quadrant, 1/2. Cos of 3/4 pi, this is going to be negative 1 over the square root of 2. The sine of pi by 3, square root of 3 over 2, that's in quadrant 1. Common denominator of 2 root 2. Isn't that lucky? And now I just have to add up my tops. 1 minus the square root of 3. Now there's a special rule that says we shouldn't have a radical in the denominator, and so what we need to do is multiply this by the square root of 2 over the square root of 2 just to make it more beautiful. And so I'm going to wind up with the expression using the distributive property, square root of 2 minus the square root of 6 all over 2 times 2, which is 4. And so this is the exact value of this rather hideous looking